Okay, so now we're going to take a look at a diverging lens. So it's got this concave shape. So just as we did with the convex lens, the first thing we're going to do is just try to understand its behavior a little bit more. So we're going to bring in some parallel rays of light, and these are representative if we could have like a flashlight or some source of light that's, we're just kind of charting out how this is going to behave with a few example rays. I'm going to bring that right to the center as we did before. Okay, so we're going to have little arrows on here indicating that they're rays of light, and these are, to the best of my drawing ability, parallel to the axis here. Okay, so in this case, a diverging lens is going to refract again, and they're going to refract such that the rays of light are going to diverge. They're going to move such that they are moving away from one another, in contrast to how they were behaving with a concave lens where everything was converging. I have rays moving away from this axis, and as we can kind of get a sense of, as you move kind of farther away from the axis, you're going to get greater and greater bending. Okay, so and we could have a ray going straight through the middle, and just like the case where we had a convex lens, we could draw this here, and it's just going to go straight through, because when you look at the interface here, it's going to be coming in at a 90-degree angle at this exact point, and so there won't be any change. So in this case, clearly, well, we're not going to produce an image here. We're not going to have a convergence point, but we do have a focal point, and we find the focal point by tracing these lines back on the other side. So if I do that for all of these rays, you'll see that they all intersect at a single point. Okay, and so they're all going to intersect if we trace them back, and this here is our focal point. Okay, so and in this case, we could take a measurement, and I've actually chosen the same F value as we did with the convex. It's 3 centimeters. Okay, so that's how we find our focal length of this lens. In fact, if this were a mirror instead of a lens, you would see reflection off of the surface, and it would all converge at a point, and you get a focal point, a focal length for the mirror in that way as well. It's very similar. And we still need this for the same two reasons that we needed it before for the convex case. One, it's characterizing the behavior of that lens. It's telling us, well, how strong is it? How much is it diverging the rays of light? And secondly, we can use that information to look at how it produces an image when we have an object. And we'll look at that next.